So this is our 7th group meeting, going over review for test number 1. Okay. Looks like we got to download a Excel file. Okay, I got mine downloaded and opened up. So question number 2. Are you ready then, Russell? All right, so question number 2, which of the following variables are categorical, excuse me. Just the second one, because that one isn't dealing with numbers. It's dealing with the brand. So we all agree on that? Okay. Question number 3. The mean IQ test score is 100. The scores that the 20 students got were 112. So 100 is a parameter. Excuse me. And then 112 is a statistic. And then 100 is a parameter because it doesn't change. And then 112 is statistic because it does change. That's just what they got from what they picked from the 20 students. All right, next one. So Russell, once you're done reading this, let us know what you think. We were kind of talking about this one before we started the call.
Okay, so we're just more focused on getting, yeah. It's just because we're doing for a class, so we've been studying.
Do you think it's stratified?
So it's a short
Divides data into similar groups.
Did anybody think a stratified one would be a good idea? Because they're two different groups with two different opinions.
So he's saying stratified because they're two different groups that have two different opinions. And it says that a stratified sample divides the data into similar groups and then takes a simple random sample from each.
I've been to
So, and that we were kind of thinking cluster,
I know that
but
mixing with
I think it makes more sense to be stratified, to tell you the truth. So we agree with you.
I think both of us have
Because they have the two different viewpoints, the opinions.
spend much time or focus on.
Okay, so for question 5, they choose a particular district, randomly select teachers, and then experiment with the students of those classes.
So
I think, yeah, I think it would be cluster.
Yeah.
it's a smaller one. And
Okay.
like Gaddy Center, it's the bigger one that we can really spend more time with more.
Question number 6. At school fundraiser, name of every person who attended was entered in the drawing. 6 names were selected.
Okay.
Yeah, just a simple random sample. That's what we're thinking. Just basic. Just picked randomly. So question 7.
Yeah, I heard his accent all the way over here.
And it's like, it didn't watch one and two in LA because it's a big city. You want to go to university,
Yeah, that's actually.
and then no, we just want to go to music. Like, why? Like, why?
What over there?
Yeah, this one sounds like stratified again to us because it's taking it from both sides.
Yeah.
Yeah. Okay. That's what we're going with.
That was funny. So we gotta tell him.
Yeah, we gotta tell him.
All right, gotta use the software.
So, free animation. Yeah, it is smaller.
What on Earth? Oh, that was really weird. My computer kind of freaked out for a second.
All time and so for this one, we're
I got 4.771.
So it depends. Yeah, and it depends. Like,
Mm-hmm.
but we can go in advance. So we're gonna go through this.
Is that what you got, Russell?
And, you know, like, if you want to go forward, if you want to
All right, question number 9.
just have like, our focus and give them that's usually what
Excuse me. 1.912.
we went to Seattle for 3 days.
1.912.
Yeah, we're
Okay, yeah.
we're just using the quantitative descriptive statistics Excel file, and we just plugged in the info that they gave us from the Crossroad Purchases Excel file, and it has all the stuff in the table.
So if people
Start by creating a histogram of the amount spent, then mark the following as true or false. Okay, true. I created a histogram. Cool. All right.
or you say like go Stanford.
All right. What's the value of the number that goes in the position marked with an A in the table. I gotta remember how to do this. It's been a while.
First, you have to like find the mean square, and then that will be
That'll be the sample mean.
bottom of it.
Yeah.
And then it just has this plug in. 37.91 minus whatever.
And that's what A is,
Yeah, that's what I think.
I think. Yeah. Did you hear any of that, Russell?
More or less. Say it again.
Basically just we're thinking for A to get the, so you know how it says X minus like, I don't know how to say it, but the line over X,
Yeah.
the line over X one, we think is just the mean of the four temperatures in the table above.
Okay.
So 37.91 plus 37.25 plus 38.98 plus 38.16, all divided by 4. I got 38.075. So we take 37.91 minus that. Negative 0.165. That's what I got. Okay. And that's what, yeah. And then for B, so what was the mean again? 38.075. Okay.
We just need to make sure if we go here.
Oh crap, messed up.
Yeah, like and
0.681. Is that what you get, Russell?
Yeah.
Okay, cool. What quantity is equal to the sum of the numbers in the squared deviations? It should equal 1, right? In all of them?
Yeah, but it's just asking us like, what is
Oh. The variance? Is that what you said? And what's the variance again?
It says the variance is the square of the standard deviation.
Oh, okay. Simple. Variance is the square of the standard deviation. Okay. So we're going with variance.
Which makes sense.
Yeah. So what is the standard deviation of these temperatures? As in, does it, the standard deviation of all of them?
That means you gotta find a really good one. I mean, if everyone in the class knows, that's not what I did.
If the right.
And they'll probably want to come. That's totally fine. So.
Oh, there's compounds or something.
So I don't know if this is like what we have to do. If we have to like find out the standard deviation of each of them and then add those up and then divide by 4. And like average standard deviations. I don't know if that's like
Maybe.
They all have different standard deviations, so I don't think that you'd have to use like the mean.
Right, like the mean standard deviation.
Right. So we found that one gives you standard deviation of the first one.
Mm-hmm.
And then like find that out for all of them. And then add them and then divide by 4. I don't know. Because I don't know how you find it. Oh wait. What did you use?
What?
I don't know what you're using. This is I've done in here. Or like there's a name which I did get. Let me get it. I did it, I found the standard deviation difference. I don't know if that's
Excuse me. So, Kaylin's saying that what she did is she took this the standard deviation of all of them. So she found it all of their standard deviations and then divided that by 4 to get like a mean standard deviation. What do you think of that?
That sounds bad.
Not exactly sure. Like,
I don't know. Like,
it's a good idea. I mean, what is the standard deviation of these temperatures? Meaning the quantity, sum of square of the numbers. So it wants it just wants the standard deviation of the temperatures that they provided. I don't know, it sounds right to me.
I just don't know.
I say we try it, and then if we get it wrong, we have one more chance to fix it.
Well,
So you did like 37.91 minus 38.075? Or, I mean, how did you find...
so I'd find this and deviation of them all.
Yeah.
Is like mean, which is the mean of all of them.
Right.
So I'd find this one, I just did 37.25 then 89 hours.
What about
39.9 minus 38.075, that's my number. And then 38.16, like the number that she said, minus the mean, and then apply that out. But I just added them together and I got 0. So I can't do that. So what I did do is put them in this original like thing. And just put the 4 points. I don't know if you can do that though. From that, when I did that, I got the same.
Right.
So I was
7.25. Let's try that. We're plugging the values into this Excel file just because Kaylin said she did it and it got the same mean. So the standard deviation is 0.715. That's what it says on here. So yeah. Mm-hmm. 0.715. Okay. That's pretty self-explanatory. I mean, they wanted us to use the files. I think that's okay. So, did you understand that, Russell?
Okay. we get it wrong, there's a simple mathematical way to do it without Excel. I mean, we could just go back to it later if you want, or we can check it now. What do you want to do? You want to just check it later?
You mean like submit it and then if it's wrong, you want to go back to it?
Well, yeah, I'm saying you want to check it now because this is how you find the standard deviation of multiple numbers. You find the mean of the numbers given, then for each number, subtract the mean, and then square the result. Then you work out the mean of those squared differences. Then you take the square root, and then that's the standard deviation.
Oh, so you cut out just a little bit. Can you explain those steps one more time?
Yeah. So if we wanted to do it by hand,
Yeah.
we find the mean of the numbers that were given to us.
Yep, which is the 38.075.
Then for each number, subtract the mean and square
Okay.
the result.
Okay, so basically just find the square deviations part of the table.
Then you find the mean of those numbers, all those numbers. And then you take the square root of that, and then you're done.
Of these numbers, then square root, answer.
Yeah, at least that's as far as I understand it. So we could go back and check
So
it afterwards if this fails.
Well,
If you want.
if we could do that right now, that'd be great, just to check it. So
Okay.
we get the mean, and then we do 30, you're saying do 37.91 minus the 38.075, and then square that.
Right. Right.
And so I
And
got
do that with all of them.
0.027, and then do it again. 725, 0.681, and then do it again. 38.98, 0.819, and 0.007. And then you said add those up and divide by 4.
Yeah. So find the mean of those.
Plus 0.681, 0.819 divided by 4. Zero 0.384.
And then take the
And
square
then
root
just take
of
the
that.
square root of that. 0.619.
Okay, so that's a bit different.
So is that what you got for it?
Yeah. But I mean, we could do either one first.
Okay. Well, I'll tell you what. Maybe we should have someone keep. I can keep 0.715, and then someone else can put 0.619 instead, and then we'll see which one's, or if either is right.
Okay, I'll put 0.619.
Okay. He'll put 0.619, and then at the end we'll check it, and we can go back if it's wrong. Okay. Under certain conditions, the standard deviation can be negative.
Real quick.
Yeah.
I accidentally erased question 12. What was the answer for that?
0.681. Mhm. So the standard deviation can be negative, can't it? Or no,
I don't think
no,
it's
it can't.
the Z-score. But I don't think the standard deviation. Because wasn't that like talking
No, I
about?
don't think it can be negative.
Um,
No, because that would mean that the curve would go like, and it can't do that.
I don't think
So false is what we're gonna go with.
Yeah, the LAX, for what?
Which local location resulted in the most consistent temperature measurements from one seal to another?
We're gonna look at
Why?
because the standard deviation is like there's the least amount of standard deviation, which means
This means the answers are closer together, and there's only 3 of them for the sample size.
They're all
That's what we're thinking, because 0.577. The smaller the standard deviation, the closer the
right.
samples are going to be.
Right.
So let's do extradural. And the number of hours represented by the box plot below. What is the third quartile? It's 8. Right?
Yeah.
What percentage of the data lies between 4 and 8 hours? Yeah, I remember doing this in a homework assignment like a week or 2 ago, and I don't know how to do it. I didn't know how to get that one. Do you know how to do this one, Russell?
Yeah, I think it's 50%. But
How do you know that? How do you find that?
well, hold on. Well, the scale runs from 2 to 12, so that means that it's 10 long, and then between 4 and 8 hours, that's 4, so that'd be 40%,
Okay.
right?
So 40% is what you think? Like, that makes sense to me.
Yeah.
Okay. So 40. That's what Kaylin got too, she said. All right. Question 19.
I'll be right back. I need to go and take some medicine.
Okay. He's going to go take some medicine. He'll be right back. So estimate the mean. Is this one the 68, 97? Oh, excuse me. That rule. So it'd be 95% because it's the mean minus or plus 2 times the standard deviation.
Also, like something that knows with the
Oh yeah. All I did was add those two numbers and
To get the mean?
the curator or maybe not the curator. Not a curator, but
I'm trying to figure out what I did.
We can try to call them. We can try to call them.
I feel like I did two separate ones.
That's probably try to call them. That's actually talking. Record. So like.
We still on 19?
Yeah, we're not sure exactly how to do it. Kaylin said that what she tried was just add them together and divide by 2. I think it seems a little simple though, you know?
That's what I'm
I feel like there's more to it.
I might have to acquire from their there's like this century that they they're almost like they're like original pictures of them. They're like
Yeah, I would think so. That makes sense. Because you're doing the mean of the measured nitrate and for drinking water. And there's 2 different measurements. Makes sense. It
He
seems
thinks
simple,
that's
but
right.
that looks right.
I don't know. Something that is like being super simple. I can sometimes try to overcomplicate it,
Right.
but then I like doubt myself because I'm like, it seems too easy just to add something.
I mean, that's, I saw your.
Well,
But
we
since
can
it's between them,
we can come back to it. It's okay. That sounds fine. We'll go with that. Right? Great. If not, we'll come back. So 2.055.
Yep.
What's the standard deviation? Just
oh wait,
sorry.
no, I was like, it gives us the thing, so I would have to solve for it.
So,
But then once you solve for the standard deviation, what do you do with the 2 values? Because you'll have 2 standard deviations. Do you get the mean of that, or
That's what I would. But again, I don't know. I suppose it's-
so
well, we could always just plug it in, but in the Excel file, you know, and it says it right there that its standard deviation is 0.658. You know,
to have the
yeah, and 2.055 is what it got for the mean as well. So, because for the test, we're allowed to use the Excel
Yeah.
anyway. So,
If it's not that inside of where we can just check for it.
yeah. So what we're going to try to do is use what Excel told us for the standard deviation, and then if it said that we can use the Excel files. So 0.658 is what I have.
I'm going to try and run the other version real quick. Remember that I was talking about earlier?
Yeah,
See if I
yeah.
get the same.
Okay, go for it. He's going to try to do it the other way.
I'm just
See if he
gonna
gets
be
the same
different
answer.
both times.
Like by hand.
3, 2, okay. Really going on.
You're cutting out a whole lot. It's really like staticky.
Yeah, no,
So
sorry, I'm thinking out loud.
okay. So for 21, I'm pretty sure because it said 68%, we use this and just plug that in.
So I
And
did
then
that.
for each values.
And these answers are here.
No?
So the closest
So wait, the mean is
the mean
2.055?
So yeah, I just get something different this way.
Okay.
But
That's something
you
different.
know, I'll run with this answer.
So what did you get for it?
I got 0.735.
0.735 is what he got.
Using my magical voodoo method, but
Yeah.
yeah, we'll see who gets it, who doesn't. That's fine.
Okay. So if you use, or are you trying it with that number?
Yeah.
Still. Confused.
Maybe we should just say 1921.
So we're a little confused because it's asking for 68%, meaning we're supposed to get the two values of the mean minus the standard deviation and then the mean plus the standard deviation, and it would be those two. But if you plug in 2.055 minus 0.658 or plus 0.658, either of those values aren't in the options they give us. So we're kind of confused.
What about my magic number?
It also, same thing. Kalen tried it and it didn't work.
closest one would be number 1, but I don't want these to be like, oh, the numbers are close.
Right. The closest they get is to the first option, the 1.357.
Okay.
But we don't. That's only like kind of close, you know, but it's not the same. I don't know. 2.055 plus 0.6576091. 2.713 and 1.397. Yeah, so we're not really sure on 21. So
Yeah, I'm a little bit lost in the sauce too. But
let's just move on for now. All right, these ones I did the other day. All right, so what is the probability that they're going to score 542.3? So we just do 542.3 minus the mean, which is, we'll score above that. Okay. 500 is the minimum, so that's the mean. Divide that by the standard deviation of 120.54. Um, what is it? Oh, yeah, sorry. Excuse me. Which lesson was this from? Do you remember?
I think isn't it lesson 5?
5? I'm confused
I don't.
because you'd think that it would be the value, which would be 542.3 minus the mean, but the mean is the exact same number,
Yeah.
so it would be 0.
That doesn't.
It doesn't make sense.
Probably that a random set of score. But the next one that it's probably the probability that a randomly selected sample score below. You just plug in 600 now. 600 minus 540.
Yeah. 600 minus 542.3, and then divide that by 120.54. So I get 0.4, and then I plug that into the normal probability applet.
This question sucks.
Point 479. So the probability would be 0.684 for question 23. Oh, the probability would just be 50%.
I just figured that out. I was like, wait, if it's the mean,
Yeah, because it's just the mean. It's a 50% chance because if the z-score is 0, it's 0.5. Because like you plug it into the thing and it's 0.5.
I feel like a moron because I literally just like reread the question again. I'm like, wait, hold on. Oh my
So
gosh.
dumb. All right.
Is it just 0.50? Or do we write it like
0.50 should be fine, hopefully.
Okay, yeah. As a decimal.
And then for the next one, we got 0.684. Is that what you got for 23?
Yeah.
Okay. What is the probability that they will score 600 or above? And that's
Oh.
just
0.3.
0.316. So what you got?
Yeah.
0.31?
Yeah. Find the one that corresponds to the 10th percentile. Gotta learn how to do that.
All you have to do is plug it in. Up here for the area.
Oh yeah, that's right. Then you do just 0.1, and then
Then you have to plug in. We have the z-score, right? So then you have to plug in negative 1.282 until you find x. So it would be like.
yeah, so it wouldn't be positive 1.282.
Because you want to see who gets at least 10%. So it's everything below 10% up to 10%. So it's negative. You understand why? If I want to find the 90th percentile, I'm going to find everything from 0 to 90. But I can't include what's on the right of it because that would be like 100%. So to find 10%, you have to do whatever's to the left. So like, for example, if you want, you could shade that one and the middle one. And then you have to plug in area, point one, and it automatically takes it away because that's 10% to the left.
Okay.
I don't know if that makes sense.
So negative 1.282.
Multiply that by the
What is she saying?
She said, so you gotta plug in 0.1 and the 2. So you plug that into the equation to solve for x.
Okay, your mic was totally bugging out. I couldn't hear a thing that you just said. Run that by me again.
So she said that plug in 0.10 to find the 10th percentile in the area of the normal applet. And then that'll give you the z-score, which is negative 1.282. And then plug that into the equation and solve for x.
I thought it had to be a positive number, doesn't it?
No, because it's I don't. She was trying to explain it to me. I didn't quite
Okay, I
understand.
don't know how to. Okay. So what's shaded to the left is 10% of the whole like.
So whatever's to the left of the negative z-score is the 10%, I guess.
So like if I wanted to find 50%, I would type
Okay.
in 0.5. Do that, and so what's to the left is from 0% up to 50%. You can't include the other half because it percent off. Does that make sense?
Okay.
So if I want to
So
find,
from 0 up to negative 1.282, that's 10%.
Okay.
so for
Okay. So just like
Does
this.
that make sense? And then you just multiply, add, and then that's x. So that gives you
The value, yeah.
Yeah.
So negative 1.282 times 120.54 plus 5 or 2.3. 387.768.
But it's whole number. So it's
Oh, the nearest whole number? 388. Is it the same for the 90th percentile?
yeah. So just plug in. Did you plug in 1.9?
Yeah.
Okay. But now you're going to use the z-score up until where the blue is shaded. So now it's positive. So that's going to change the
Oh, use the positive z-score. Oh, okay.
90% of people are going to score higher than 10%. That makes sense?
Yeah, yeah.
Did you come to consensus about 25?
Wait, what?
Did you come to a consensus about question 25?
Is that what you got?
No, but it's fine. I trust you.
Well, what we did was you plug in 0.1 for the area, the z-score of negative 1.282. Then you
Right.
plug that in as the z-score in the equation equals x, which we're trying to find, minus the mean, which is 542.3. All of that over standard deviation, which is 1.54. Then solve for x to a whole number, so it's like 387 point, 388.
Right.
That's what we did.
All right.
Same thing for the other one, except it's a positive score. So it'll be, instead of negative 1.282, it's positive 1.282, and it's the same thing, just solve. Find the first quartile, meaning the 68%? Or
No. So you're going to find the first 25%. So it's 25, 50, 75.
oh, so plug in 0.25.
And then all you have to do is use the z-score for that, plug it into the equation, and get the score.
The negative one,
Right. Because it's only
because it's only the 25%. Okay. So plug in 0.25, z-score is negative 0.674 times 120.54 plus 542.3, 461. Third quartile, plug in 0.75, and then it'll be the positive z-score, 0.674 times 120.54 plus 542.3, 624.
What was that?
So for question 28, the third quartile means 75%. So in the applet, plug in 0.75 and then just use the z-score, the positive one, to solve for x.
I didn't hear what you. Did you guys talk about 26 and 27?
Well, 26, you just plug in 0.9 for the area, and then use the positive score and solve for x.
Okay.
Step.
Okay.
That makes sense?
Yeah.
And then for the next one, the first quartile means 25%, and so we just plugged in 0.25, and then use the negative z-score, solve for x, got 461.
Okay.
Then question 28.75 for the third quartile. Then we got 624. And for question 29, I'm pretty sure it's the same as the regular mean. I remember that from the reading. The mean's the same. So the distribution of sample mean is the same as the mean, meaning it's 542.3. What is the standard deviation of the distribution of sample mean scores? So we got to do we use for x. Would we use 500? I don't know, because that's the minimum required, you know? So anything above that? What? So 500 minus 542.3. And divide that by 120.54 divided by the square root of the sample size, which is 15. I got negative 1.36 or 359.
Because that is self-predicting score.
Right.
And
Oh,
I just realized.
divided by that.
Oh, well maybe we should use that to equal.
Wait, what is it? Sorry.
I was looking at divided.
Trying to remember. I do not know.
Oh, here, we can go back.
31 I can do.
31.
So we're going to skip that one and just move on to 31 for now. So 600 minus 542.3 divided by 120.54 divided by the square root of 15. And then plug that in. $1.854. 0.032 is what I got. So for 31, do you know how to get it? The answer?
You're talking to me?
Yeah.
No, I'm not sure on how to do that equation.
So the value for x is going to be 600 because we want to know 600 and above.
Mm-hmm.
So we have to find the z-score. And then once we find the z-score, we just plug that into the normal probability applet. And then everything above, so everything on the right side, not the middle or the left side,
Mm-hmm.
will be the answer. Or that'll give us the area, which will be the probability. So 600 is x, so we just plug it into the equation. 600 minus the mean, which is 542.3, divided by the standard deviation divided by the square root of the sample size. So you can divide it by 120.54 divided by the square root of 15 because n equals 15.
Right.
And then you should get a z-score. And then just plug that in. And everything to the right is, it'll show the area to be 0.032.
Yeah. Okay.
And that's the probability of everything above 600 and above. So, does that make sense?
Yeah.
Okay. So which ones did we miss again?
Oh, 30. I just found it. The standard deviation of the distribution of sample mean scores for all such samples. To find this, where did it go? Right here. Standard deviation of sample means is just the standard deviation divided by the square root of n. And we have n. So it would just be 120.
Yeah, 120.54 divided by the square root of 15. That's all it is? 31.123.
What?
So I guess this for question 30, the standard deviation of the distribution of sample mean scores is just the bottom part of the equation. Or in other words, the standard deviation divided by the square root of n. That's it. And because n equals 15, then we just do 120.54 divided by the square root of 15. That's what we did. And we got 31.123.
That's all I got too.
Okay. What was the other one we missed?
We need to figure out 19, 20, and 21.
19, 20, and 21?
Because technically we got answers for 19 and 20, but none of them was the last answer. So this one, and then
It doesn't make sense. Because,
this equation right here that it gives us is for the 95th percentile. I don't know if that
right. But it asks what two are between the 68% for 21. Sorry.
Oh.
So for 19, well, I think 19 and 20 are right. Well,
So I got 11, 14, 18, 21 wrong.
oh, you submitted already?
Yeah.
So wait, which ones were wrong?
So, I mean, let's just make sure, because I know some of them I typed in different answers.
Okay, so
So, question 11,
question
I-
11.
I put negative 1.65. I think we all put that.
0.165.
Negative 1.65 is incorrect.
We put 0.165. Negative 0.165. Yeah,
Negative
right?
0.165?
Yeah, that's what
Oh,
We put
we put.
that's okay. That's probably an error on my part. Question 13, I put
13.
the variance.
That one's
That is
wrong.
incorrect.
What? Okay.
Question 14, I put 0.619. Did you put that too?
For 14.619 is wrong. No, we put 0.715,
Okay,
which
that's
is what
the
it says in the Excel file.
Okay, yeah, so the probably just follow the Excel from here on out.
Sure.
Question 18,
18.
40
Okay.
is. Oh,
40 is in.
I probably wrote it incorrectly. We're probably supposed to put. No, the answer then put only 60. No, okay, yeah. So the answer 40 is incorrect.
Okay.
Okay. Question 20. The answer 0.735 is wrong, and I think that's another one that I did on my own, wasn't it?
Yeah, we put 0.658, and that's what it says
In the
for the
Excel.
standard
Yeah, that's probably
Excel.
right.
So
And 21 is also incorrect.
it's not the
The-
first option.
No, it is not.
Okay.
And then finally 29.
And then 29.
So we put 5.3. That is incorrect. But everything else is 28,
Wait,
30.
what is
31.
it? Sorry for 29?
5.3.
No,
incorrect.
542.3.
Oh, another crappy error on my part. 540.
It should be exactly the same as the mean.
Okay. Yeah, my mic has been chopping up your voices. Like, there's literally like periods of time where I just don't hear anything.
Yeah.
So I'm like looking at the test, and I just don't hear anything, and then you guys are on like another number, and I'm like, what the crap? Okay.
Yeah, it's dumb. Okay, so for 13, what quantity is equal to the sum of the numbers in the squared deviations column? And what was the thing for variance?
variance. Square of the standard deviation.
So maybe just one of them is this. So one of them is the variance, but all of them together. So all of the variances are what? So if we add them all up, what do we get? For 13. If we add up all of the squared deviations column, what does that give us? That's what I got. Maybe it's none of the above. If it's not the very... Here, let me plug in the value of L, and that'll give us the standard deviation and the mean. You know, 37.91, 37.25, 38.98, 38.16. So the mean is 38.075. The standard deviation is 0.715. The variance is 0.511. So it's none of them, because I don't see that value at all on here. That's what I'm going with. So for 13, we're going to say none of these is correct. I don't know why it says is correct. None of these are correct. Come on. I know it's not English, but really? And then 18, it's not 40. Yeah, this is the one I didn't know how to do that I got wrong. So I will not be very much help because I didn't know how to do it for the homework back then either. Three? Okay. Oh, you know what? On this one, on the homework quiz for lesson 3, it's the same thing. It's the same exact box plot and everything from 4 to 8. And it's the right answer is about 50%. Now, thinking about it now, maybe it's about 50% because that's the first quartile and the third quartile, meaning 75 and 25. If you subtract it, you get 50%. Does that make sense?
Yeah. It's half of the
So just
stats.
50. Yeah. That's what I think, at least.
That makes sense.
Yeah. Okay. I'll be out in
Okay.
a couple minutes.
Okay. I'll go ahead and submit mine, Russell, and then I'll let you know if we got others wrong.
Okay, go for it.
19, 2.055, 20.658. Oh yeah, 21 we got to do. I forgot. Now this one I don't understand because hey babe, I'm still at my meeting. Yep, it's a long one. Yeah, I'm still here. Probably like 20 minutes. I haven't really looked. I don't know, but I'll call after this. Well, I don't know what to tell you. I would. I love you too. Okay, bye. Sorry about that. Yeah, this one I don't understand why it's not right, or why they don't give us. And I don't know, because it gives us the 95th percentile equation in the information it gives us. The mean minus 2 times the standard deviation. That's the 95th percentile. So
Did we wait? Say it again.
I don't. So you know how if you want to find the 95th percentile, it's the mean minus just or 2 times the standard deviation. And then for the 68%, it's just the mean minus the standard deviation, not multiplied by 2, just that, or plus or minus. That was less than 5.
Number 2.
Why?
Okay. So I was like thinking about it. The mean, which would be 50%, right?
Right.
The mean is 2.055. So it's asking between what two measured nitrate concentrations with probably 68% of the data values are. Sorry, no, that's because approximately 50% of the data is 0 and 2.055. So if you
Maybe the 4th one. It's just a wild guess, though.
yeah, something.
Just because I'm thinking, so we have values 1.59 and 2.52. So try to think of 68%. Which numbers would kind of be 68% between that?
Well,
The closest would-
2.52 is the 98 percentile. So
The what? Sorry?
The 98 percentile, because it gives us the equation for the 98.
You mean the 95?
I mean,
95th percentile?
yeah, so 2.52 is like the highest 98. So maybe it's the last one, 98%. I don't know. We could go with number 3.
I was thinking the last one.
Oh, you were?
Yeah,
Oh,
because if you think about it,
okay, that's what I was thinking.
1.823 to 2.288 seems like 68% of 1.59 to 2.520. You know,
Oh, I
that's just a guess there.
because I was guessing before.
No, it's okay. I'll do it, Russell. Don't worry about it. All right, I'll do that. You can wait. Okay. So we got all the other ones though. Wait, what was question 3?
Is that 3 long?
No, what was question 3? I didn't save it. Oh, it just didn't save. Sorry. No, I got it. Okay, let's submit. Load. Missed 1. Question 20 was wrong.
What was it?
0.658 for question 20 is wrong, but that means that the 4th answer is right for question 21.
Estimate standard deviation of the.
That's what it gave me in the thing. This is so frustrating because now I don't know what's right
Okay, well,
and what's not.
this. Right.
It's just confusing me for the test because now I'm not sure if I'm doing it right because of this.
Okay. Estimate the standard deviation of the measured nitrate concentration in the is
Okay. Well,
What?
yeah, I gotta get rolling. I gotta get going. out of bounds to get some food.
Okay.
So,
Well, just the only one that I had wrong was question 20. It's not 0.658. So,
yeah. Yeah. All right. I'll see y'all soon.
okay, sounds good. See you later. So, let's try to figure out why that one's wrong. Is what, sorry? Fourth answer for 21.
Estimate the standard deviation of the metric function. I don't know, because if you solve the standard deviation for each of them, the different values are listed. What do you do? Oh, so it's like 233. That's what it is. I'm so dumb. Because they both when you solve it, that means it's going to be this. Because if you just 0.233 times 2 and then plus 2.055 gives you 2.52. And then you can shake it up and you do minus 2.055 minus 2 times 0.233. That gives you the standard deviation is 0.2. It has to be it. It has to be it. We put in 0.2. No. Oh my goodness. So dumb. That's how you do you got it. Oh, you got it right. You got them all right. You can, at least for all of them. What you do is yeah, show you. Go back. See what each one. It's this thing. New submissions. And you click on whichever one. It's got two text. You can click on whichever submission you submit. And then look at it just like this. All right, let's end this video. Okay, we're done. Bye.